Okay, so basically review of functions. We're just going to play with the graphing calculator a little bit. It is definitely something you need in this course. Over the course of the course, we do a lot of regressions, which is we have the calculator come up with equations for us. Those equations model something. Okay, it could be a quadratic, which models the path of a kicked soccer ball or whatever. So when you're using a graphing display calculator, it's important to choose appropriate window settings and to label the graphs correctly. So let's say we're graphing the square root of x. Okay, y equals square root x. If we use the default setting, which is on the left there, so you can see it goes from -10 to 10. Now the problem is the graph of the square root of x is only in the first quadrant, right? This is quadrant 1, quadrant 2, Q3, and Q4. So if it's only in the first quadrant, why don't we just graph the first quadrant or look at that? So these are our window settings. Okay, so it says, and this is actually on the formula sheet. So it says this is your minimum x value, this is your maximum x value, and this is your scale. Okay, so just make sure you leave a blank behind her. And this is your y minimum y value, maximum y value, and your y scale. So it says you're going from 0 to 3 by 1, so this would be 1, 2, 3, and 0 to 2 by 1s, this is 1, 2. And the reason we want to do that is, well, we know that the square root of 3, well, the square root of 4 is 2. So the square root of 3 is a little bit less than 2. And so we only want to go from 0 to 2, right? There's no point going 0 to 10, because when you get out to 10 here, that square root is only like 3 point of something, right? It's just a little bit over 3. So it's better if we can kind of fill the window. Okay, it's easier to look at. I have to figure out how to move this thing. There we go. Okay. Explain why the settings on the right are more appropriate. So the graph exists only in quadrant 1. So we set the window to cover that. Okay, then when it gets to the end, you just pass it over and then you just write your name next to the people that are there. The graph exists only in quadrant 1, so we set the window, so the graph fills the window. The graph now, if we're graphing something contextually, that is, that we know our x values are the amount of time. Let's say we kick a soccer ball, it's in the air for 6 seconds, right? So we say, well, we're going to go from 0 to 6, and then it reaches a maximum height of 25 meters. So we'll go from 0 to 25 or 30. Okay. So we want to set it so it fills the window, as opposed to not filling the window. So if this were the soccer ball, it's doing something like this. We don't want to see just this part of it, and we want to say it only exists for positive x values and positive y values, so we don't need to see the whole grid. So we set the window accordingly. Okay. So we're going to graph each of the following functions with a graphing display calculator. So if you don't have yours here, you want to follow along later, you've got the video. And when I do key presses on the calculator, you'll see them on the screen. Okay, so you won't see them here, but on the recording, they'll show up with little hovering blue or yellow or whatever. So what we're going to do is we're going to record the window settings we use for each of these guys. We're going to sketch the graph. We're going to label the graphs accordingly, etc., etc. So I want to graph y equals x. So get out your graphing calculator. Right place. That's from like a math course like 15 years ago or something. So they come off the wall, they don't deserve to be there. So we're going to graph y equals x. So here's what you're going to do. Get a graphing calculator, turn it on. when you first start using it in any test, it's always going to be cleared. Let's just practice clearing. So you go second function. Okay, you go second function, and then the plus sign to get into the memory menu. You want number 7 for reset. You want all. Easiest way to get to all is one left arrow takes you to all. Hit enter, and then reset is 2. So if you run into any problems on your calculator, like you're into a list and you realize it's giving you some error, you don't know what it is, it's the middle of the diploma exam, you stick your hand up, some social studies teacher comes over, they're not going to know the calculator. So what do? Just reset it, start over. Okay, so that's the easiest way. So you should all by now know how to reset. It has them a couple of years, but if anybody has an odd calculator, like a TI-89 or something, just let me know. Okay, we'll check and make sure that it's an allowed calculator. That's fine. Let's just go. Okay, we'll check those. Just there are certain calculators that aren't allowed. I'm pretty sure that. But if you have anything that's not like a TI-83 or 84, let me know. We'll check it over. Okay, so go to y equals. We're going to graph y equals x. Okay, when it's cleared, you get the default window, which is negative 10 to 10 for your x's and negative 10 to 10 for your y's. So we look at this and we say, that window is okay, right? Like, yeah, there's nothing up here or here, but I can't sort of cut off my x's or y's because the graph goes all the way. So we're going to say, all right, that window's fine. So let's sketch it out. There's x, there's y, there's 10, there's negative 10, there's 10, there's negative 10. So my x's go from negative 10 to 10 by 10s. Now, normally you would just do that by 1s, but I don't want to have to put all those ticks down, right? But, you know what, let's just say we're going by 1s, and I'll just throw in some ticks. Now, if it were on the diploma exam and you're graphing it, make sure you've got the correct number of ticks, okay? And your y values go from negative 10 to positive 10, again by 1s. And there's your graph. Okay? This is a linear graph, right? It's a straight line. This is linear. Okay, stuff you studied in what says linear, right? It's of degree 1. The exponent on the x would just be a 1 if you could see it. But, you know, if we can't see an exponent, it's just a 1. The domain is the set of all x such that x belongs to the real numbers. And the range is the set of all y such that y belongs to the real numbers. Now, there's a written component to your diploma exam, right? And every test we do is going to have some written component to it. And if it asks you to list a domain and range, you kind of have to use proper notation. But a lot of times, just if you look somewhere else on the exam, you'll see a domain or range written, so that that'll help you say, oh yeah, that's the proper notation I should use. Right? I see how they wrote it here. Okay, any questions on that first one? Right, graph we're very familiar with is linear. One that we're even more familiar with is quadratic, because that was a lot of 20-2. So that's x squared. So what I'll do, it's a new graph. I'm going to go zoom and then 6, zoom standard. The standard window is the window that goes negative 10 to 10 and negative 10 to 10 for the x's and the y's. And we can see that, all right, for a quadratic, that doesn't really fit, right? Since you're squaring every number, any negatives when they're squared are going to give you a positive. So we don't need anything down here. So and here's the other thing, right? We're squaring numbers. So when you square 3, you get 9. So there's no point in going out to 10, right? If I go out to 10, I'm going to have to go up to 100. So let's do this. We'll say, let's go from negative 4 to 4 by 1s. And let's go from 0 to, let's go to 16. Because we know that 4 squared is 16, right? So that will fit inside the window, in the grid that we're going to give it. So my graph's going to look like this. I'm just going to go reset the window. So negative 4 to 4 by 1s. And 0 to 16 by 2s. Okay. Actually, you know, I can go 0 to 16 by 1s. That would be fine. And the reason is there will be 16 ticks if I do that. That's okay. Let's call that 16. There's negative 4. There's 4, 3, 2, 1. Negative 3, negative 2. Then you put something that resembles 15 ticks in between, right? For 1, 2, 3, 4. And we're going to hit graph. So we see, okay, what does this look like? Okay, it looks like this. And this. So that's nice, right? It fills the entire window, right? So the graph fills the window. You know, if I go negative 10 to 10, so I was going to do that. You know, say, so what would it look like with negative 10 to 10? Well, it would look like this, and then what we have is, this is really restricted, right? It's sort of like, well, you're only looking here, but you've got all this space. So it's better to go negative 4 to 4. Now, as long as you're somewhat reasonable, like if you went negative 10 to 10, I wouldn't take any marks off as long as you drew it correctly, right? It's like, yeah, okay, it's not the greatest, but it's not wrong. What's the domain here? What x values can I take? Sorry?
Actually, go ahead. Okay, I'm just going to guess negative 4 and 4.
Okay, well, that's specific to this window, but domain is what x values. So what numbers can I square? Or, let's ask it this way, domain, what number can't I square? Can I square negative? Well, here's negative 3, right? So it works out to positive 9 when it's squared. Is there any number I can't square, multiply by itself? No, you can do that with any number, right? So the domain is all real numbers, okay? So often with domain, what we really want to ask is there a value that I can't use? Like with a square root, you can't take the square root of what? Of a negative number, right? You can't do the square root of a negative. So if you're doing square roots, your domain is going to be greater than or equal to 0. And that's how we set that window, right? So let's go from 0 up. There's no point in doing negative values for a square root because you can't take the square root. Now, if I'm squaring things, what's my y value? What's the lowest y value you can have? 0. So my range okay, so write that down. I'll read this to you in English. What does this actually say? So a brace bracket, imagine this is a brace bracket, right? It's like the best I can do. A brace bracket means the set of. And when you look at your formula sheet, because we do set theory, we actually study sets, it'll be on your formula sheet saying this is a set, right? If it's inside brace brackets, it's denoting, it's indicating this is a set. So this is the set of all x. The vertical line is translated such that x belongs to the reals or is an element of the real numbers. This says the set of all y such that y is greater than or equal to 0 and y belongs to the real numbers. Okay? That's a very formal domain. Okay, if you're planning on later doing 30-1, this is how you must list a domain. A lot of times we'll just say y is greater than or equal to 0, right? And that may be good enough for us. But again, if you look somewhere on the exam, the diploma exam or a test, you should see it written out. So it'll give you an idea. If I have to write something, I should stick to this form. Okay, questions on quadratic, which you spent like 2 months on last year, right? Cubic. So I'm just going to kick up here and replace the 2 with the 3. I'm then going to go zoom zoom, standard. I'm going to go back to a standard window because like I said, I don't know what a cubic looks like. Maybe there's stuff down. Oh, look. There's stuff down here. Okay. And I can see, yeah, it's a good idea to go from -10 to 10, but I'm cubing numbers, right? So 1 cubed is 1. What's 2 cubed? So 2 times 2 times 2. 8. What's 3 cubed?
27.
Yeah. Okay, 3 cubed is 27, right? So if I want to stick from -10 to 10, then let's take our window. Let's just say, let's go from -3 to +3 by ones. And let's leave that as -10 to 10 by ones. Okay, let's see what we look at. So when you're doing a window, maybe the first time you change the window, it doesn't look great. So you can do it again, right? So you work a few times, and you know what? Okay, this is good enough. This shows me what a cubic looks like. Okay, and in a few days, well, not a few days, in the second unit, we'll be studying cubics. Okay, so the graph looks like this. We said let's go from -3 to 3 by ones. Let's go from -10 to 10 by ones. Sorry, let's just indicate that's x, that's y, that's x, that's y. That's 2, 1, 2, 3. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. -10. There we go. So there's my x-axis, there's my y-axis. I'm going from -3 to 3. I've indicated that up here in the window. Going from -10 to 10, that's also indicated. Is there any number that you cannot cube? That is, multiply by itself once and then twice. Any number you can't cube.
0.
Okay, what's 0 times 0?
0.
What's 0 times 0 times 0?
0.
Okay, we can cube 0. Right?
Yep.
Okay? Can we cube a negative? What's -2 times -2? +4, right? Times -2 is -8. So we can cube negative numbers. As a matter of fact, when we cube a negative number, we get a negative number, right? Because you'll have a negative times a negative times a negative. An odd number of negative signs will give you a negative answer, right? Because the first two will pair up and make a positive. And then times a negative will be a negative. Okay, if I can cube any number, then my domain is all real numbers. Now, if I cube a negative and get a negative, and this keeps going down, and that keeps going up, what can we say about our range?
All the real numbers.
All the real numbers. Okay, with a quadratic, it's only positive, right? You square a negative, you get a positive. Okay, any questions on cubics? All right, looks good. Let's move on. All right, here are some graphs that we're going to learn about this semester. So there's a sinusoidal, okay, and if you look at your course outline, it lists them. It's got the first two in the wrong order, but you'll see there's a unit on sinusoidal, there's a unit on exponential, there's a unit on logarithmic. Now, all we're going to do today is just graph them. So later on, we will be going into detail as we hit each unit and graphing these. So don't worry too much about any of the characteristics or anything. Just going to show you, okay, hey, this is how we graph it. This is what it looks like. So for a sinusoidal, it says make sure you use the window stated. Okay, so if you're following along, the window is going to be -2 and then a pi, right? So pi is second function and whatever that is, to +2 pi. And we're going to use pi divided by 2. And our y values, we're going to use negative 1.5 to positive 1.5, and we'll go by ones. And I want that. Yeah, I want that to be 1. Okay. And and what are we going to graph is y equals, and I'm just going to clear that and go sine, show me a sine of x. Okay, yeah, question? Yeah, go up there, sign out, time. So time, there's a clock up here, which is almost right, or use your phone, whatever, I mean, you know. So that's a sinusoidal function, right? Now we got a unit on this, so don't worry about it. This is what it looks like. We'll get into much more detail on it. Okay, so that's the graph of it. So, okay, that's 2 pi. That's 1. That's negative 1. Don't worry too much about this, right? It's not important that now you walk away knowing all of this, right? Just that you see it and you say, okay, it's of this particular shape. And so basically it's just a wave. It's actually called a sine wave. So just a wave. It's a varying function. I mean, it can describe various things. So if you think about, say, temperatures in Calgary, right? So in the summer it's hot, and in the winter it's cold. In between, it's kind of in between. And you know, so if this is winter down here, say December, you know, then this is like March, and this is June, this is September, and this is back to December again. So the temperatures vary in that wave-like pattern. Something else that varies like that would be hours of daylight. Okay, so if you think about it, there are now fewer hours of daylight. Well, how many hours of daylight are there? You ask, so the sun rises at 7 and sets at 8 p.m. Okay, so right now we have from 7 to 8 p.m. like 15 hours of daylight. No, 7 to noon is 13 hours a day. Can you do math? 13 hours of daylight right now. Right, our longest day of the year is when?
It is the
December
summer
21st.
It's the shortest day of the year, the longest.
The summer June 20.
Yeah, June 20-ish.
23rd. That's the summer solstice.
Yeah, the summer solstice is the longest day, is when we have the most daylight, right? And then the winter solstice, December 20 whatever, 20th, 21st, is the shortest day of the year, right? We have the least, and if you think about it, in between those two, hours of daylight vary each day in this wave-like pattern, right? So that's what sinusoidal is used for. I will give you the domain and range. So the domain is a set of all x such that x belongs to the reals. And the range is a set of all y such that y is between -1 and +1. Okay, so whenever we express a range, it's always the low value is less than or equal to the variable, in this case y, which is less than or equal to the high value, and then y is an element of the real, right? Just meaning you can get any y value out of this function that is between -1 and +1. You want 0.75, you can get 0.75. You want 0.743, you can get 0.743. Right? You can get any y value between 1 and -1. And you can put in any x value you want. You want 1,000,000, put 1,000,000 in there, it's fine. Right? You go to your calculator, go y equals sine, put 1,000,000 in, you'll get an answer. Okay? Next type of function is an exponential function. It's called exponential because the variable is in the exponent position. Okay, don't worry about that. We got a whole unit on it. We will discuss it in great detail. For now, we're just going to graph what does this thing look like. All right, we go back here. So I'm just going to go to y equals, clear that out. I'm going to put in 2 to the power of. So if you want to kick up to the power of, it's this little thing here, the upside down v between the clear and the divide. Anybody know what that's called? It's called a caret, C-A-R-A-T. That's the name of that symbol, right? You just think of it as to the power of. So I go to the caret that kicks me up top, superscripting it, right, and to the power of x. Okay, don't know what that looks like, so I need to go zoom 6 to just say, hey, reset the window to -10, and let's get an idea what this looks like. Looks like nothing. Where it's graphing. Oh, no, there it is. If you're graphing and nothing's happening, which in this case kind of looks like nothing's happening. If you're graphing and nothing's happening, you should see a little box up here. I think I broke it. You'll see a little box up here. So the calculator saying I'm working on something. And if you don't really see anything, you can just hit on, and hitting on will stop it, right? It just says stop what you're doing. Okay, and then I'm going to try again with the graph. Okay, here we go. This time it's working. Now here's just a little thing up there. Okay, that's an exponential function. We're going to study that. You want an what's an example of exponential growth? COVID-19. COVID-19 is an example of exponential growth, right? Here you are. You live at that time where the math gets real, and you say, hey, so we'll learn more about this as we get there, right? Yep. Yeah, okay. Nobody else has signed up, so here, let me just turn on. All right, so there's an exponential function. So looking at this, we can say there's no negatives down here, right? It starts out here, it goes up. Now, it goes pretty quick. So you think about if x is 1, 2 to the 1 is 2. If x is 2, that'll be 2 squared, which is 4. If it's 3, it's 8. If it's 4, it's 16. So you know what? We're going to say window. Let's go from like a -5 to +5, just for symmetry. And we can go from 0. Now, if we're going to 5, it's going to go to like 32. So I'm going to say 32. And we'll go by 2s, right? If I go 0 to 32 by 1s, you're just going to see a lot of ticks. It's no big deal, right? It's just your y-axis gets a little fuzzy if you do that. Okay, and then I'm going to hit graph, and we'll look at this and say, hey, that looks like a pretty good graph, right? I mean, it fills the window nicely. We did that by saying, let's go -5 to 5 by 1s, and 0 to 32 by 2. So each of these ticks is 2, 2, 4, 8, 2, 4, 6, 8, 10, 12, and so on. Okay, let's graph that. Okay, so I'm just going to say, here's 32, minus 32. Okay, so here's 32. There's -5, there's 5. And the graph looks like this. Okay? And, you know, I should put some ticks in there. I'm not too worried about those, right? You're showing other stuff. There's this thing about an asymptote. We don't study asymptotes, but an asymptote is a line that a curve approaches. Notice this is coming down to the x-axis, but it never really gets there. And so the equation of the asymptote is y equals 0. That's the line y equals 0. You are in no way, shape, or form responsible for knowing anything about asymptotes. Okay? Now, if you are going into 30-1, you are definitely responsible for knowing about asymptotes. Domain. So it says, is there any number I can't, 2 to the power of? Can I do 2 to a negative? Well, yeah, because there's stuff here. Right? Like 2 to the -3 will be 1 over 2 cubed. And we'll do that in a sec because we do some, so set of all x such that x belongs to the reals. And the range. So you can't get 0. So it's y is greater than 0. And y belongs to the reals. Okay? Again, we will learn as we do the unit on exponentials, we will go into all of these characteristics. Okay? So a lot of what we do with these functions is we look at how does the equation of the function compare to the graph of the function. So if you give me a graph, I can tell you certain characteristics of the equation, which means you give me a graph, you give me some equations, I could pick out which equation goes with which graph, right? Based on certain characteristics, which we will learn about for each of these guys. And then the other thing is, given a graph, what are the characteristics of the equation? Or give me an equation and give me a graph, I can tell you which graph it is. Again, based on looking at the equation, I know there's certain characteristics the graph has. Okay? And we'll look at those for each of the units that we're studying. Last one. So y equals log. Anybody do chem use logs? Yeah? Do you know what they are? No, it's a key that I hit on the calculator because there's this equation in chemistry that says log, and so I just hit that. Well, we'll learn what logs are. Okay, for now, I'm going to go zoom 6 again. Let's graph this. Don't know what it looks like. Okay, now you can't see it, but this line actually does this. Okay, so I'm going to say, that's okay, I wasn't talking. For the window, it's only over here, so my x min can be 0. So we'll go 0 to 10 by 1s, and my y values, they don't go that high, but we can go negative 10, and we'll go to positive 2 by 1s. Okay, so 0 to 10 by 1s, and negative 10 to positive 2 by 1s. We'll hit graph. There's 10, there's my x's, there's 2, there's negative 10, there's some ticks. Okay, and there's the graph. Okay, so again, this is all just intro stuff, right? We will spend a few days on log graphs, right? So we'll get into what are the characteristics of these, how does it match up with the equation, et cetera, et cetera. For now, we're just sort of seeing, okay, that's what a log graph looks like. And then that's how I should do my, draw my graph. The equation of the asymptote, so the curve never is going to touch or cross the y-axis. Okay, you don't need to know asymptotes unless you're planning to do 30-1. Domain is the set of all x such that x is greater than 0. And the range is a set of all y's such that y is an element of the range. Now, exponential functions and log functions are related to each other, right? And we'll talk about that later on as we go into them, right? As we do those units. Okay, so for now we're just graphing it, we're getting some characteristics, we're looking at what makes a good window for the graph. Okay? So that's all we're trying to do right now. Just kind of see them and say, well, what's going on? Okay. Any questions on any of those? So this video will be up later. Okay, so if you didn't have your calculator here and you want to practice with your calculator, you can pull the video out. You can watch each of the keystrokes. You can slow it down. If you're watching keystrokes, you can slow it down to like half speed so that things happen a little bit slower. If you're looking for a particular explanation of something, I kind of missed that when you did this part B with these functions. You can just go back, scrub to that point, and watch that if you need to see that over again. Okay, so remember, a function is a relation where for every x value, there's only one y value. The graphs have several relations. Circle the ones that represent a function. Okay, so go ahead. There's like 6 of these guys. So if it's a function, if for every x value there's only one y value, circle it. Baseball in and out. That's So you think back to grade 10, the big thing about functions was the vertical line test. It's the one you could never use as a reason. You couldn't say it's a function because of the vertical line test, but you can use it. Oh, look, I can draw a vertical line. So this x value has two different y values. This is not a function. Same here. That is not a function. Here's a graph, okay? So just some kind of weird graph, right? Just indicating something. We don't know what. State the domain and range. Okay, so domain is x values. Okay, so you tell me just from where to where. Okay, so domain in English it goes from -5 to 6. Okay, so in math, a domain is a set of x values. It's a set of all x values such that it goes from -5 to 6. So here's the way that we say that. So we start with the low value, the -5. You then write less than or equal to. You then put the variable, so x. So it's a set of all x such that -5 is less than or equal to x, which is less than or equal to 6, and x is an element of the real. Make sure that. All right, I think this might do. Everybody had a chance to put their name on this, right? Okay, what's the range? So where does the range go from to? -2 to 3, right? Okay, so you try writing out the range. How do you think that should look? I was thinking, where do you think you're going? You said, I don't know you well enough yet to I could destroy some. Yeah. No. Okay. And for those of you paying attention, these numbers, like I point out them, right? These numbers just changed because they were wrong. So now they've been changed. And they're wrong. State each of the following. So what do you do when you state something? You see instructions say state. What are you required to do? You just give the answer, right? State just means we're only interested in the answer. That doesn't mean that you don't need to show any work or you don't have to. You may still choose to show some work, and that's fine. Okay, what is f of -2 or f at -2? What's that in English? If you're going to translate that, what would that say? Okay, sorry, what was it? Yeah, function of -2. It's saying, what is the y value? What is the value of the function when x is equal to -2? Right? So instead of us having to write out the value of y when x is -2 is, we just write f bracket -2. So when x is -2, what's y? Is equal to 2. So that says f of -2. It says, what's the value of y when x is -2? So you find an x value of -2, you go up or down to the function, you get the y value. What is f of -4? -1. What is f of 0? -2. If f of x is -2, Now, whenever you see f of x, you can always replace that with y. So that says when y is negative 2, what's x? So here's how you do it. You say y is negative 2. That is literally the line y equals negative 2. Right? Anywhere on that line, the value of y is negative 2. So what x values do I get? Well, x can be negative 5, x can be 0, x can be positive 3. Each of those x values, when you put it into the function, will give you a y value of negative 2. What's f of 4? If y equals 3, right, again, you see f of x, that's y. So just go along the line where y equals 3, right? When is y 3? Anywhere along this line, y is 3, then the x value is? So what's x? 4. Any questions on that? Well, good. If f of x, so here's function notation of quadratic, right? So then evaluate. So what's evaluate mean? So literally, it just means find the value, right? What is the value of f of 0? What's f of 0 mean? It's the value of y when x is 0. So we go to the function definition. That's this guy, right? That defines what our function is. So function definition is like a recipe, like a way of getting it. It's like, how do you get the answers? Well, take whatever's in the brackets and square it. From that, subtract 3 times whatever's in the brackets. And then add 2. So that's 0 minus 0 plus 2, which is just 2. Okay, so evaluate. What's 3 times f of 5? So if you kind of pattern match this, right? That is, you look at this and then you look at this, and you say, I see a 3. Okay, so that 3 must be this 3, which means the thing inside the square brackets must be what? Well, 3 times something. So whatever's in the square brackets, that must be this, f of 5, right? So it's 3 times. Now, what's f of 5? Well, f of 5 says square the 5, subtract 3 times the 5, and then add 2. That's in a set of square brackets, right? So it says do this first, then multiply it by 3. Okay, so 25 minus 15 plus 2. I don't like stringing equal signs along a line, but I kind of ran out of space, so didn't have much choice. So if you're looking at that 3 square bracket block, square bracket, and you look back at the 3 times f of 5, you should be saying, I got a 3 times something. So whatever's in that square bracket, that must be the something, which in this case is f of 5. Quadratics. Circle the equations that represent quadratic functions.
Just for the answer,
Yep.
for B, do we have to own a test? Do we have to do every single step, or can I just skip from like 5 squared minus 3 times whatever? Can I just skip to like the answer?
Yeah, you get it wrong, I'm going to take off almost all the marks. You show your steps, you lose maybe a half a mark. Okay. So the more you want to do it once, the greater your chance of making a mistake somewhere.
Okay.
And on a diploma, show as much as you can. Okay. Because on a diploma, the whole reason for the written is to see what you can write. And I'll tell you right now, because I've marked them. If you don't show enough stuff, you won't get any marks. Okay. So like just going to an answer, like answers are worth nothing. Like literally, if they got the correct answer, they show any work? No, they get nothing. So, it doesn't hurt to show more. Okay. Less chance of a mistake, and if you do make a mistake, then it's a minor, right? It's like a half mark off, not sort of, oh, you got it wrong. Circle the equations that represent quadratic functions. Okay, so there's all different forms of quadratics there, and there's stuff that isn't quadratics. So circle the ones you think are. Do this, we'll summarize. All right, so for those of you at home, everything's appeared now as if by magic, right? So no x squared, right? Not a quadratic. That's a 2 to the x. This is actually an exponential function. That's a linear function. That's an absolute value function. That's a vertex form of a quadratic, so it's a quadratic. That's a standard form of a quadratic. That's a sinusoidal. That's another standard form. That's a cubic. It's got a 3. This is not a quadratic because the quadratic is in the denominator. That makes this a rational function, okay? And that's actually our first unit is on rational. That's a square root. It's a radical. That's a rational function again. There's no x squared, but it doesn't matter, right? So the x squared has to be by itself. It can't be in the denominator. That is the factored form of a quadratic. So if you expand this, which would be x squared plus 2x minus 8, then you would see that's the standard form of a quadratic. For each of the quadratics, state the properties listed. Okay, x-intercept, so we got 0 and 4. Don't put parentheses around that, right? It's just those two numbers. If you go bracket 0, comma 4, you're really listing a point. Y-intercept, the y-intercept is 0. Coordinates of the vertex, okay, that's here. That's at 2, negative 4. Equation of the axis of symmetry. The axis of symmetry is a vertical line that runs through the vertex. That will be x equals 2. This opens up, so it has a minimum value. Okay, it's a minimum value of negative 4. Okay, it opens up, so it's got a minimum value. That minimum value is negative 4. The domain of every quadratic is a set of all x, such that x belongs to the reals. Okay, there's nothing that you cannot square and then add or subtract some multiple of x, and then add or subtract a constant. The range, since it opens up, its y is greater than or equal to the minimum value. So it's a set of all y such that y is greater than or equal to negative 4, and y is an element of the reals. Okay, any questions on that one? So that kind of pushed through that relatively quickly, but you spent like 2 months on quadratics, right? It's like half the quadratic stuff I ever read. There's quadratic equations and quadratic functions. Okay, what are the x-intercepts for this guy?
2 and 4.
2 and 4. What is the y-intercept? Negative 8. What are the coordinates of the vertex? 3, 1. Oh, don't apologize, we want to lose marks on. So remember, it's x comma y. What's the equation of the axis of symmetry? Okay, it's not 3, right? It's x equals 3. So the axis of symmetry is a line. Equation of a line that's vertical or horizontal of the form x equals or y equals, right? So vertical line up down is x equals, and a horizontal line is y equals. Does it have a minimum or a maximum value? The maximum value of 1. Domain? Yeah, all real numbers, right? So when do domains change for quadratics? When there's a context, right? Think of the kicked soccer ball. It's in the air for 6 seconds. Our domain becomes from 0 to 6, right? Because there's a context and there's no point having negative numbers. Well, 12 seconds before I kicked it, it was 30 meters below the ground. That's not going to happen, right? 25 seconds after I kicked it, it was 300 meters. No, like 6 seconds after you kicked it, it hit the ground. That's it. Then the range will also have a context, right? We go from 0 to however high the maximum height is. So quadratic can have different domain and range depending on a context to a question. And the range of the question here, or the range in question. So it's a maximum, then all the y values must be less than or equal to the maximum value of 1. Any questions? All right, let's move on. Quadratic equations. Solve 2x squared plus 12x plus 13 by graphing on your graphing calculator, round to the nearest hundredth where necessary. Okay, so turn this guy on. I'm just going to clear it because this actually clears pretty quick. So, all right, so we're going to go to y equals. We're going to plug in the equation 2x squared plus 12x plus 13. We're going to post. Okay, so we are graphing what? 2x squared plus 12x plus 13. 2x squared plus 12x plus 13. So we don't finish this. I'm just going to finish it on my own, but we'll finish it in class tomorrow before we do the next part. Okay? So, I mean, if you wanted to go home and watch the rest of it, that's fine. There's not too much more to go, but the interruptions have cost us time. Okay, let's just go zoom standard. So we want to find the x values such that y is 0. That's these guys. Easiest way, the way I like to do it is, I also go to y equals. I go down to y2 and I set that equal to 0. Now on the color calculator, you're going to see that red line. On black and white calculator, you won't see that line. It's just going to be drawn over the axis. But it's there, so I have 2 lines. So I go second calc, intersect. So I'm looking for where do these two, y1, which is this guy, and y2. So the way I do intersections is I just move to about the point of intersection. So let's just go to the left one. You can also do it with zeros. It's just a bit more of a pain doing it with zeros. So your calculator is asking, what's the first curve, right? The blue one here. What's the second curve, the red one? Notice it just sort of jumps down a bit. And what's your guess? So by moving to the point of intersection, all I do is hit enter, 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 right? First curve, second curve, guess. I don't have to move around. And it tells me that it's at negative 4.58. So to the nearest hundredth, right? So x is equal to that, and x is equal to, so again, second calc. Because I put y2 in, right, I've got the red line here. You won't see it on a black and white, but it'll be there. Move to about the point of intersection, just hit enter 3 times. And we've got negative 1.42. Okay. So watch your rounding. Rounding counts on numerical response questions, right? If the answer is 2.66 and you put 2.67, it's wrong. The answer is 2.67 and you put 2.66, it's wrong. There is no leeway. They don't say, well, if you're within, okay? Never any leeway. It must be exactly rounded. One way to do that, if you go into mode, move down onto float and over to 2, okay? So what you're saying now is round to 2 decimal places. If I then go back to the graph and do my intersect again, okay, and it's about in the right spot, so I'm just going to hit enter 3 times. It'll do the rounding for you. See that? Negative 1.42. So if you have problems with rounding, you can let your calculator do the rounding for you. Then once you've done that, just go back to mode and reset it to float. Okay, and you'll be good. All right, solve by factoring. Express solutions as exact values. So this factors, it's a difference of squares. Okay, now tomorrow we'll get into factoring because it's a part of the review stuff for rationals. Because rational is going to involve a bunch of factoring. So that's a difference of squares. The factored form is x plus 11, x minus 11. Whenever you factor, FOIL it back out, make sure that you've got the signs right. Usually you'll get the numbers right. You'll end up with the wrong sign. So when you're supposed to have a plus something, you have a minus something instead. Okay, so just FOIL it out, check it. So you know this gives x squared minus 11x plus 11x will be 0x minus 121. So that means, well, you know what, let's solve this. It means that x plus 11 is equal to 0. So x is negative 11, that's this guy. See, either this is 0 or this is 0. X minus 11 equals 0, so x is 11. All right, I'm going to halt it here. All right, class time ran out. I'm just going to finish this. So this only has x's in it, so we can factor an x out. Right, so it's only two terms, and it's only factoring with two terms. It's either a difference of squares, which is this guy, or there's a common factor, which in this case is the x. So either x equals 0, or 5x minus 9 equals 0. 5x is 9, and x is 9/5. So this has two solutions, 0 and 9/5. Notice we want exact values. This guy we're going to try and factor, right? So it's just a matter of saying, are there two numbers that multiply to 70 and whose difference is 9? So I'm thinking, okay, let's try 7 and 10. Well, they multiply to 70, but the difference between them is 3. All right, what else goes 70? How about 14 and 5? So with 14 and 5, we'll have, so the larger number, 14 times 5 is 70, and 14 minus 5 is 9. So the larger number has to be negative, x minus 14, x plus 5. Now, anytime you factor, you check x squared. Plus 5x minus 14x will be minus 9x minus 70. So you factor, you check. That checks. X minus 14 is 0. X equals 14. X plus 5 equals 0. X is negative 5. Okay, sorry. Let's finish this off. Sort of got delayed. So we're going to factor this guy. So, sorry, it's equal to 0. So the only way this can factor is if we have a 3x at the beginning and an x afterwards, right, in order to get 3x squared. Minus 4, so that comes from either 4 and 1 or 2 and 2. But you see I got an 11 there, so if I put plus 4, see this will give me plus 12x, and then minus 1. So let's check this. Anytime you factor, you got to check things. So we've got 3x squared plus 12x minus 1x will be plus 11x minus 4. And that means that either 3x minus 1 is 0, so 3x is equal to 1, and x is 1/3, or x plus 4, excuse me, equals 0, and x is negative 4. So that is factoring, right? And we've got an exact solution, so we don't want to write that as 0.3 or some rounded version of it, right? We want to leave that as 1/3. And this is x equals negative 4. All right, solve using the quadratic formula. So sometimes we use quadratic formula, we get an actual solution, which is nice, like fraction numbers, and sometimes we get exact values, we've got radicals. So let's just do these two examples here, and let's see how they work out with quadratic formula. Okay, so what I do with quadratic formula is I'm going to identify a, b is negative 5, c is equal to 1. So from here, right, it's ax squared plus bx plus c, so we've got the negative 5. We're going to plug that in. So x is equal to, so negative b, negative 5 is 5, plus or minus the square root of b squared. So that's the quantity negative 5 that's being squared, right? Negative 5 squared is 25, minus 4 times 2 times 1, okay, and then extend the square root symbol, the radical sign, over 2 times a, 2a, 2 times 2. So 5 plus or minus the square root. Anytime you're squaring a negative, so whatever b is, whether it is positive or negative, when you square it, you're going to get a positive.
4 times 2 is 8 over 4. Okay, I'm just going to scroll this down a little. Okay, obviously that's not the way. I could do that here. Hang on. Okay, so 5 plus or minus root 17 over 4, and that's basically where we leave it. Okay, that's your answer. You actually have two answers, right? X is 5 plus root 17 all over 4, and x is equal to 5. Oops. I need an eraser. That note. Cross. 5 minus root 17 all over 4. Okay, so those are our two answers. Okay, this guy's same deal, right? So A is equal to 8, B is equal to 8, C is equal to -1. Okay, plug in. X is equal to, so negative B, right, is going to be negative of 8. B is 8, so the negative of 8 plus or minus the square root. I always put this in brackets, that way if it's negative, I just remember I'm squaring a negative, -5 squared, you're going to get a positive, and if it's positive, alright, hang on, let's hope we can get through this, minus 4 times 8 times -1, so, over 2 times 8. Okay, I'm going to pause and go get a... Okay, we have the power. I mean, we're almost done, but... Okay, 8 squared is 64, minus, so 4 times 8 is 32, that's -32, minus -32 will be plus 32, that'll be 16. So 64 plus 32 is 96. Now, the largest square, let's go off to the side here, root 96 is, so 96 is 16 times 6. We picked the 16 because it's a perfect square, right? So we get to split out root 16 root 6, which is 4 root 6. So this is not a big part of this course, but it is possible that this might happen. It's an old cough. It's not new. I've been talking all day, so. All right, so you notice everything is divisible by 4, so we're going to do this. I'm going to take a 4 out. So 4. Let's go -2 plus or minus root 16. Okay, so 4 times -2, that's the -8. And here, down here, we're going to go 4 times 4. So the common factor is a 4. And then x is going to be -2 plus or minus root 16 over 4. Okay, that is 4 root 6. Hey, I figured out how to erase. Ha-ha! So that's 4 root 6. Take the 4 out, that'll be a root 6. Sorry, right? 4 root 6 is set up there. Whoops. Got the eraser. Woo! Learning stuff. Okay, and that's a 6. And there we go. That's the answer. That's the end of the video. And let's say we're done. Okay, catch you on the next one, which will be factoring strategy, and I'll try and get that up. We're not really sure what's going on because it's Tuesday, September 8th, and we just don't know what's going on. But we'll figure it out and we'll get back to you